Now the second problem, which is based on the Thevenin's theorem, find the current through the 10 ohm resistor. That means we have to find the current through this 10 ohm resistor. As we know that through which we have to find the current, we are considering it is the load resistor. Now the 10 ohm here is a load resistor, and the first step for the Thevenin theorem is calculation of the VTH. For finding the VTH, we are removing the load resistor. Here the 10 ohm is the load resistor, so we are replacing 10 ohm resistor from the network. So simply suppose the terminal A and B, through the terminal A and B we are replacing the load resistor RL. Now here we have to find the first step is VTH. Suppose the terminal A is plus and the terminal B is minus. Here the terminal A and B is open circuited, so the no current flowing through this loop. Now the current only flowing through this first loop. Suppose that this terminal is plus, so current flowing from the positive terminal, and here the terminal is plus. So suppose I am considering the anti-clockwise direction, because the upper side of the voltage source is positive, so current flowing from positive terminal always. Now we are applying or finding the current through this different two loops. So suppose the current flowing through the first loop is I1 and the current flowing through the last loop is I2, and there is no current flowing through the VTH loop. Now we are finding the current I1 by applying the KVL in the first loop. Firstly applying KVL in loop 1. So simply suppose, as we know that for applying the KVL we are using the sign conventions, so the current I1 is in the clockwise direction, so simply from this terminal to this terminal, so starting terminal is plus, end terminal is minus, plus, minus. So suppose we are starting from the 50 volt source, the current flowing from minus to plus, so simply we are considering it as rise in voltage and it is positive, so simply it is 50. Now for 6 ohm resistor, plus to minus, fall in potential, so it is minus 6 into I1. Again for the 4 ohm, it is from plus to minus, so it is minus 4 into I1 is equal to 0. But by solving this equation, we get the value of I1 is equal to 5 ampere. Now applying KVL in loop 2. See here we are considering the anti-clockwise direction, so through 5 ohm resistor current flowing like this terminal to this terminal, so we are considering starting terminal is plus, end terminal is minus. So again for the 15 ohm resistor it is plus to minus. So simply we are starting from the 20 volt source, current flowing like this in that direction, minus to plus, so simply it is plus 20. For the 5 ohm it is minus 5 into I2. For the 15 ohm minus 15 I2 is equal to 0. By solving this we get I2 is equal to 1 ampere. Now we are applying KVL in VTH loop for finding the VTH. Now see here in this loop there is no any current flowing because it is open circuited, but we have to consider the sign convention of the previous currents or previous loops. So we are not changing the sign conventions of 4 ohm and the 15 ohm resistor. Only we are considering the loop direction for taking the equation is in the loop. So suppose we are starting from the VTH, the current flowing like this or direction is like this, A to B, so simply is plus to minus, so we are considering it as minus VTH because it is falling potential. For the 15 ohm we are going from like this clockwise, so plus to minus, so minus 15 into I2 because the current flowing for the 15 ohm resistor is I2 only. Then for the 4 ohm resistor we are going like this in clockwise direction, so we are going from minus to plus, so simply it is plus 4 into I1 because through the 4 ohm resistor current I1 is flowing. Then for the 2 volt source it is we are going like this minus to plus, so it is plus 2 is equal to 0, and by putting the values of I1 and I2 in this equation we get the value of VTH is equal to 7 volt. Now the next step is calculation of RTH. We will calculate the value of RTH. We know the step how we are calculating the RTH. The step 2 is calculation of RTH. Simply we are replacing this load resistor RL with the RTH, and all the voltage and the current sources replacing with their internal resistances. Here there is no any current source, so simply we are replacing the voltage source by short circuit because the internal resistance of the voltage source is 0. So see here, the 6 ohm resistor, this is the 6 ohm resistor as it is, then this is the 50 volt source, we are short circuiting the 50 volt source, then this is the 4 ohm resistor as it is, then 2 volt source is short circuited, then here we are replacing the load resistor with terminal A, B, and here we are finding the RTH. Now here the 15 ohm resistor as it is the 15 ohm resistor, then this is the 5 ohm resistor, and this 20 volt source we are short circuiting. Now see here, the 6 and the 4 ohm resistor are in parallel, 15 and 5 are in parallel, and this parallel combination will be in series. So simply RTH is equal to 6 in parallel with 4 plus, because this parallel combination is in series with this parallel combination, so simply 15 parallel with 5, 6 parallel with 4 plus 15 parallel with 5, we get the value of this is 6.15 ohm is the value of RTH. Now the last step, we are replacing the network in series with RTH, VTH and the load resistor. So simply the Thevenin network is, that is the VTH in series with RTH in series with load resistor, that is RL. We know the value of RTH, it is 6.15 ohm. We know the value of VTH, it is the value of VTH we get, it is 7 volt. So simply VTH is equal to 7 volt and RL is equal to 10 ohm. This is the value of RL. RL is 10 ohm. So we have to find the current through this load resistor. The last step is we are applying the Ohm's law in this loop. So simply IL is equal to VTH upon RTH plus RL. So by putting all this value, VTH is 7 volt, RTH is 6.15 and the RL is 10 ohm. We get the IL is 0.43 ampere. This is the final answer. Thank you.